Hello everyone, this is Singh Shekhawat and today we are discussing our part 2 of Google Docs system design. So in part 1 we basically discussed how you can design systems like Google Docs. In this part specifically we will focus on the storage part. Okay, so once we say that this is our Google Docs system, actually these docs will be stored in some kind of database, right? So what could be this database? What kind of database we might require to solve our use case? Before moving forward, if you haven't subscribed to my channel MsDeep Singh, so consider subscribing. I keep on making content around distributed systems and system design and complete deep dive on analysis around large scale systems, so we'll learn a lot of things. So consider subscribing and do like the video and share it with your friends. So okay, so once you have done that, I believe let's move on to like what are the requirements we have. Definitely for deciding the storage system, this is the storage I require. Let's say I want to use S3. So before saying that I want to use S3, why do I need to do it? So for doing that, or like for specifying that, we basically need to specify that these are the storage requirements we have. Okay, so when we say storage requirements, the first one is we want to store the document content. Okay, so we want to store the document content, like whatever you are storing in the document, A, B, C, D, E, F. So whatever, all these content should be stored in some database, right? So this is our first use case. User information like credentials, preferences. Definitely you will also need some kind of database to store your user credentials. Okay, this is my user, handsome sa ladka Mandeep, and this is trying to access this doc one. Okay, so do this user is authenticated or not? First of all, we want to know that is this user authenticated or not. Then we will check for the permission that yeah, this document can be accessible to this user or not. Got it? So we need some kind of information at a user level. Whenever a user signs up and creates a Gmail account, we need some kind of user information and preferences of this user basically. So this is the second requirement. Then document metadata like document ID created by it. So also along with the content of this document, we also need some kind of metadata associated to it, right? So let's say this is one metadata. What is the doc name? Okay, then we will have some kind of document ID. Definitely this is, let's say, title. Then we have, let's say, document ID. Then when it was created, who created this document, when this was created, creation time. So these kind of things we can store in our metadata DB for faster access. And so yeah, okay, so and additionally you can also store who all users have permissions to document. Okay, so you can also store user data which can contain like these are the users which have these kind of permissions. Definitely along with permissions you can also say that this is the permission which a user has. So let's say this is your permission and it has read, write on those similar lines. So this is our third requirement, user series sessions database for WebSocket connection. This actually we discussed in our last video. So we were using Redis there. So we will not be focusing on this part specifically in this video, but just to call that out that we discussed that in our last video. So if you haven't checked that video 1 or like part 1 of this series or this Google Docs system design, do check that out. You will get the basic understanding of how the system, overall system looks like at a high level. Fifth requirement is document collaboration data. So user actions or comments. So basically we also mentioned that there can be some there can be multiple users interacting with the same document, right? And there can be some comments associated to these users. So we want to store that information as well, how the different users are interacting with the same document which is shared with them. There is some note associated. I'm talking in terms of database choices from AWS. So mostly I have worked with AWS, so I'm talking in design choices in consideration to AWS, but definitely like there are related services of Google Cloud as well or Microsoft Azure as well. So Google Cloud is definitely not using AWS, but there are related services to AWS as well which are used according to it. So I will try to add all the links in the video description. There you can find information around how the Google Cloud services are compared to AWS, or like what are the replacement products for whatever the products are offered by AWS. For like a simple example could be AWS offers Aurora as a fully managed MySQL or Postgres data store or relational data store, and Google Cloud offers Cloud Spanner. Okay, so I will share the list of documents with you where you can see these kind of comparisons and how you can use them. Okay, now let's move to our first requirement. In here, what are the basic requirements for this kind of, like, what are the requirements for choosing, like, what are the main parameters basically if I want to select the database. So first one is strong consistency. We are looking for a strong consistent database. Now this strong consistency can be supported by multiple databases, but let's look on the different requirements we are seeking for. First one is stronger consistency. Then we are looking at higher availability and scalability. Therefore definitely this is a need, because we are talking at a scale. There are a lot of users which are trying to access the documents, and along with it there are a lot of users which are trying to work on the same document. Further, like the first another one is content stored in chunks of for easy change management. So we discussed in our last video that we want to store the documents in some tree kind of structure. We specifically discussed there how you can use Merkle tree to use for version management. So if you store in this way, right, if we store in this way, it's easier for managing all the changes and all these things. Got it? So what are the different choices you can take to support this use case? So if you say strong consistency, right, the first idea that comes to your mind might be rdbms. So there are a lot of choices. The one example we took, right, Aurora or Google Cloud. Now but if you see current non relational databases as well, they have the support for stronger consistency. Let's say DynamoDB. Amazon has this key value or document store, which is DynamoDB, DDB we call it. So this is a NoSQL data store which has also a option for stronger consistency. Definitely there are two options from which you can select. There is an eventual consistency and there is a stronger consistency, but definitely there is choice that you can go with strong consistency as well for the reads. So if you, like, in general discussions, if you just say that stronger consistency mean that I have to go with rdbms, that will be a wrong statement to go about it. Okay, higher availability and scalability, definitely, like in this statement, like in the first statement, as we said that rdbms can be the strong choice. In second option you might say that NoSQL is a stronger choice. Why? Because they have higher availability and scalability, because they are by default designed for horizontal scaling, but that you can achieve in rdbms as well. So these kind of things you don't have to mention that since I need a scalability, I have to move with NoSQL, right? You don't have to say that. That will be completely a wrong statement. You can achieve all those things in all kind of scenarios. Got it? And another one is that we want to store the chunks of we want to store the complete document in chunks, right? So why you want to do it? It's like basically we discussed, right, that we want to do it because for the easier change management and easier access. Okay, so for this, let's discuss how you can actually do it. Let's take one example and then discuss around it. So if we say the complete document will be presented by the root. Got it? Now if we say, let's say this is your document. Let's say this is your document. Let's use a different color pen. So let's say this is your document. Okay, this is your title doc1. This is your section 1. Okay, in this section 1 you have paragraph 1 and you have multiple lines, line 1, line 2, and in all the lines you have, let's say, word 1, word 2 on those lines. Similarly you have section 2. In this you have multiple paragraphs, paragraph 3, paragraph 4. So on these lines you might have got the gist. So how you want to store is like this is the one way. Definitely like I don't have a complete documentation or a complete references where I can say this is the exact way how Google Cloud is designed. Not the Google Cloud, Google Docs is designed, but this is one way to go about it, as I think as I thought about it. Okay, so this at a root node you are storing the complete document. Then you have divided this. So let's move from like bottoms up manner. So each leaf node represents the words. Okay, the words, the entire words here which are in the lines. Okay, so these are represented by the leaf nodes and they are further combined to more complex structure. So these words make up a line, then multiple lines make up a paragraph, and then let's say in here we can say we have a sections here. So multiple sections form multiple paragraphs. A section can contain multiple paragraphs. Got it? So a section, you can just say that it's your heading, right? Now in a single heading there can be multiple paragraphs. So this way you are trying to design a document in a tree-like structure. Okay, so these all are your child nodes, and then this is your root node, which is your complete document. So node can have multiple attributes. Definitely when you actually store the data, right, when you actually store the data, so let's say this is your data, that subscribe MsDeep Singh. Okay, so you have entered this text. This is your, let's say, word 1, and this is your word 2. So when you say when you use this kind of terminology, right, or you are, let's say, storing this document, storing this data in your Word document or my Google Doc, what you are trying to do, this is your just a word, but this MsDeep Singh contains a link in between. Like in Markdown we try to write like this. So in here you will have a YouTube link. So whenever you click on it, that it is redirected to that URL. So what you are trying to do is, there can be different attributes that are associated to the words which you have stored. This might be in the bold as well. Okay, this word might be in the italic. So these kind of attributes, how can you do it? You can associate attributes key value map to each node where it can contain any kind of attributes there. So let's say the content. What is the actual content? Content is the word 3 is bold. Is this data bold? It's true. What is the hyperlink? So this is the link of the YouTube channel. So these kind of things you can maintain in my attributes which are associated to the nodes. Now these definitely these attributes can be associated to any kind of nodes here for storing any kind of attributes that are required. Now let's talk around the databases choices we have, or like we can select from. So I try to compare, like I try to use both the relational and non-relational databases for solving this use case, and both seems to be fine, and they were like about to, or like they were kind of solving the use case. So definitely you can add the comment section in your viewpoint how you think around it and what could be the best solution to go about it. Okay, so our first choice is relational DB, and we are going ahead with the Aurora. In case of Google, we have a Google Cloud Spanner. So Aurora, or you can use RDS as well. Okay, so RDS has different kind of DB engines you can select from. In Aurora you just have MySQL and PostgreSQL. If you want to use another DB of my relational databases, you can definitely explore around RDS, but Aurora definitely is designed for better scale and faster reads and writes. Got it? So if we say Aurora, definitely there will be multiple tables, right? Relational table, we tend to create multiple tables and then try to establish relation between them. So first one is our document table, which stores document ID, title, and document root node. This root node specifically here, complete document root node, which maps to the complete document data. Another one is we have a nodes table. In nodes table we are trying to store all the nodes. Okay, node ID, basically who is the parent ID, then node type, paragraph, line, etc. Okay, then attributes map, whatever the data we are trying to store in case of key value map. Got it? So another one is collab table. In collab table we are trying to store the collaborator email, then permissions to specific to that collaborator to the specific document. Okay, so if we say that, right, these table should be sufficient enough to solve our use case of storing the data. We just take this example, right? If I want to get all the data for a particular node, so what I can do for a specific node ID, I can start from the root node, and then I keep on iterating the data, or I can directly start from the child node. If I will get the node ID, and then I will directly start from the child node and keep on getting parent node, like whatever the use case may be, but this is the one structure to go about it. Now database choice 2 is our DynamoDB. In case of DynamoDB, we can use like either we can use DynamoDB, or we can also explore around Google Bigtable. Okay, so if we say I want to use DynamoDB, there can be two scenarios, or like there can be two ways you can actually store this document. One way is you dump the complete document in this kind of JSON format. Okay, so this is the one way to go about it. Another way is the same structure we are trying to maintain as per our relational database schema. So let's discuss on the first way, in which what we are doing is we are keeping the partition key. We are keeping the partition key as document ID, and we are keeping the sort key as a creation time. So if we say a certain example, if we take this certain example, this is, let's say, document ID, then the title is subscribe to my YouTube channel, creation time is 2022, author is MsDeep Singh. So content could be that this is the content section ID, and then type is text, and then content is hello. Similarly, you might have some kind of images in which you might have a image link. Let's say just you are dumping the image to S3, so you will have an image link to that S3. Okay, so this is the one way to go about it, but there are certain issues with dynamis can provide just specific node entry update instead of querying for entire document. But if, like, let's say in this kind of scenario, right, if you're trying to store the entire document, what if you try to update a specific content, right? You will have to figure out, you will basically have to iterate through the entire document. You will have to figure out where this node is located. So that's not a good way to go about it, because there are multiple users we mentioned, right? And it can be a huge document. So this might not be this might not be properly scaled for our use case. So another way to go about it, this is also I added it here, that as discuss size grows, it will become difficult in continuous update for real-time collaborations. So definitely this doesn't seem to a very good design, but there is other way to go about it. What you can do is you can think around similar schema as we had in our relational table, like Aurora use case. So we can think around the similar use case. What you can do, so let's say you have these attributes. You have node id, then you have parent node id, and then you have child node ids. Your node id is your partition key, then your parent node id is your sort key, and your child nodes are the nodes along with attributes. So basically how can you, let's take this example. So your doc1 is basically a root node which has multiple sections, and then each section can have multiple paragraphs. This is your basically parent node. So these are your child nodes, para1, para1, para2. So for para1 you have parent node as section, then it has child nodes as line 1 and line 2. For line 1 you have child nodes as word and word 2. Similarly, word 1 has no child nodes because it's the leaf node. So this is the one structure to go about it. So if you compare these things, right, the information around figuring out node ID when multiple users are contributing can be derived with combination of user input. So it's just around like how you can actually figure out the node ID. Basically, if you want to query in this data, query in this table, or query in this table specifically, you will need to figure out the node ID. So how you can do it? You can figure out by taking the user inputs, because user have the entire document, right? So by using that information along with our collab service, you can figure out what is the node id, and according to it you can make the update there. Got it? So this is the general way. And if you compare these two databases, right, if you can compare the RDBMS and you compare the DynamoDB structure, both seems to be serving the use case, and both seems to be serving our requirements of these things. Like stronger consistency, we can definitely provide that in case of RDBMS, as well as you can provide that support in DynamoDB as well. Now in general, like if we talk about in general scenario, NoSQL databases are generally preferred for eventual consistency. But if you see the support, right, if we see these requirements are being met, so definitely we are able to solve the use case. And don't forget to add your suggestion in the comments, like which database you think is better choice here for going to solve this use case. Now let's quickly discuss our other use cases, which are kind of shorter. This was the most important one in this case, that how you will actually dump the document in your database. Okay, so the other use cases are kind of small, there where you are trying to update. Let's say you keep the user information. You can generally use your relational DB, user email credentials and preferences. Okay, so we definitely need this as well. This system as well is strong consistency, and then you need a strong ACID properties support there. Just around the transactions, right, in the last video we mentioned that we will need a distributed transaction kind of support. So if we use DynamoDB as well, the DynamoDB has a support for transactions, so you can have a strong ACID support there, where you try to commit into multiple rows in together, or multiple tables in together. So DynamoDB has that support of transactions both in case of read and write, right? So you can easily use this information, or like you can easily use this support. So that's not stopping you by using NoSQL, and like there is no strong use case that you only have to choose the SQL database, because in our scenario both of them seems to be solving our use case. Okay, so let's move to final around document metadata. So we are trying to keep document metadata. Again, in this use case as well, we can use Dynamo or Aurora. depending on like how we went ahead with our first use case. So we can select the same database just to avoid the churn around like maintaining two kind of databases that will definitely need expertise in two of the databases. If you are comfortable with DynamoDB, we can go about using the same in this as well. So in this document metadata, we are storing document ID, then created by creation date, and then access permission for a specific user. What are the permissions to that user? Okay, in case of user sessions, we have already discussed this, that we have a Redis with persistent storage, and finally we have a collab data. This will work in sync with document storage DB. Definitely whatever update is being done by multiple collaborators for the specific document, we want to keep that similar. Let's say the comment section or the suggestions or document update info, who updated specific document node. So we need this kind of information just to, so if you have used Google Docs, right, you might see that cursor that this was updated by this person, this is the person who is updating right now at this particular node. So how can you can actually do it? So collab service basically are responsible for holding that information and providing that information in real time, and passing that information via the operations queue we were maintaining via the WebSocket handlers we created in the front-end service. Okay, so finally, like around this comment storage, I just took this example how you can actually store the comments, that you have document ID, then you have comment ID with specific node. This comment is associated to, and then information related to content comment. So it is author, date, and the particular content of the comment. Okay, this could be your partition key, this could be your sort key, but definitely if you see Google Docs, right, there is also a use case that comment has a reply to comment, and it has a reply to comment. So these kind of scenarios will not be served by this, right? So you will have to somehow optimize this, where you have to maintain who is the parent of this particular comment, who is the parent of this particular comment, to figure out the complete hierarchy, that this is the comment one, this is the parent, then this is the comment. So you need some kind of hierarchy maintenance there. So these are the things we generally have to consider while you actually think it. Definitely I'm not sure if this is a perfect solution. Google Docs work on scale. I try to deep dive it on at my end. I try to gather all my thoughts, and it should solve the use case, but definitely there can be more things which can come in picture on how if you actually implement this kind of system. So you can definitely share any resources which you have, or like any information or any suggestions you have around the content, and we will meet again. Before that, don't forget to subscribe. I'm MsDeep Singh, and this is my LinkedIn और Instagram handle. So don't forget to subscribe. हम मिलेंगे यार अपने next video में, where we'll be discussing more around system design and deep diving into distributed systems. तब तक के लिए stay safe. टाटा, bye bye.